This video is a continuation of the previous video where problems 1 through 8 were worked. This will be 9 through 16. Number 9, see we have 13 plus 3j is equal to 9j minus 17. Notice we have the variable j on both sides of the equal sign. When we do that, we're going to eliminate one of them. On the right side expression, I have a positive 9j. I will eliminate that by subtracting 9j. Whatever I do to one side, I do to the other. 9j subtracts 9j to leave r minus 17. In this context, we'll call it negative 17. Equals in the middle. 3j minus 9j will be a negative 6j. 13 remains the same. We want to get our variable j by itself. We will undo this 13. It's a positive 13. We'll subtract 13. Whatever we do to one side, we do to the other. 13 subtracts 13. Notice this subtraction here. Make sure you hold on to it. In this context, it becomes a negative. Here it's a subtraction. Here it's a negative. Equals in between. Negative 17 minus 13 will be negative 30. If we want to get the j by itself, we notice negative 6 is multiplied by j. I know that because they're connected. So I will divide by this negative 6, the coefficient. Dividing by negative 6 on both sides. Negative 6 divides negative 6 to leave j. Negative 30 divided negative 6 is a positive 5. We will take this possible solution 5 and substitute it to verify. 13 plus 3j. 13 plus 3 times what we think j is, substituting the value j is 5. Is it equal to 9 times j? Again, where we think j is 5 minus 17. 3 times 5 is 15 plus 13 will be 28. 9 times 5, 45. 45 minus 17, also 28. You can enter this statement in your calculator to check, but that's indeed true. Since we yield a true statement, j equals 5 is a solution. Number 10. We notice we have a number connected to a parentheses. We'll begin by distributing. On our right hand side, 2 times minus 4 will be minus 8x. 2 times minus 13, minus 26. On the right hand side, I will keep my expression negative 37 plus 3x. Again, we have variables on both sides. We can't combine them. They're on opposite sides of the equal sign. So in this case, I'm going to undo my minus 8x by adding 8x. What I do to one side, I do to the other. Minus 8x plus 8x goes to 0, leaving my negative 26 on the right, equals in the middle. 3x and 8x is a 11x. Still have our negative 37. We want to isolate our variable x, so we will deal with the added or subtracted part first. In this case, minus 37. We will eliminate that by adding 37 on both sides. Negative 37 and positive 37 cancel, leaving 11x equals in the middle. Negative 26 plus 37 is a positive 11. 11x equals 11. I hope you can see that x must be 1. I'll divide by my coefficient 11 on both sides. 11 divides 11 to leave x. 11 divides 11 to leave 1. We'll take this 1 and substitute it back in. Negative 37 plus 3 times 1 for x, is that equal to 2 times negative 4 times 1 minus 13? Negative 4 times 1 is negative 4, minus 13 is a negative 17, times 2 is a negative 34. Negative 37 plus 3 times 1 is 3, that's also a negative 34. This statement here is true. Since this statement is true, we can say x equal 1 is a solution. Number 11. Here we have a fraction equaling a fraction. This is referred to as a proportion. an equation where we have two fractions set equal to each other as a proportion. We can, one very easy method for solving a proportion is cross multiplying. We'll take 2 times m, and that simply yields 2m. 20 times 7, that is equal to 140. Now we have this very simple equation. We have 2 times m equals 140. Solving for our variable m, we will simply divide by our coefficient 2. 2 is being multiplied by m, the inverse is divide. Whatever we do to one side, we do to the other. 2 divides 2 to leave m. 140 divides 2, that's 70. Now I can take my 70 and substitute it back in. I'd be left with this. Instead of m over 20, we have 70 over 20. Is that equal to 7 over 2? Well, I hope you can see they are equal. Here we could, dividing both of these by 10, you'd see that we'd have 7 over 2. 70 over 20 is indeed equal to 7 over 2. Again, cross multiplying, we can see that. 70 times 2 is 140. 7 times 20 is 140. So this is a true statement. So m equals 70 is a solution. Oftentimes when you have a proportion, you can simply think about what multiplier would get you from one to another. That is, 2 times what is 20? Well, 2 times 10 is 20. So in the numerators, we'd have the same thing. 7 times 10 would be 70. All right, number 12. Again, we have our proportion. A fraction equaling a fraction. I'll cross multiply. 6 times 2n minus 1. Well, I can simply rewrite that using my distributive property. I'll rewrite that simply by connecting the 6 times the parentheses. Next, I'll be able to employ the distributive property to actually multiply that out. In this direction, I'll do the same thing. 4 times n plus 3 is 4 parentheses n plus 3. We know connected means multiplied. To multiply 6 times this difference, we simply connected 6 to a parentheses with that. 4 times n plus 3 is 4 times the parentheses n plus 3. Now I can use my distributive property. 6 times 2n is 12n. 6 times 1 is 6. We preserve our operation. Equals 4 times n is 4n. 4 times plus 3 will be plus 12. Now we have an equation where we have variables on both sides. I'll eliminate one of my variables. In this case, this positive 4n by subtracting 4n. What we do to one side, we do to the other. 4n subtracts 4n to leave 12. 12n minus 4n is 8n. Minus 6 remains. Solving for n, I'll add 6 to both sides. Minus 6 plus 6 leaves 8n. 12 plus 6 is 18. Dividing both sides by the coefficient 8. It's 8 times n. We undo with the inverse operation, division. 8 divides 8 to leave n. 18 divided by 8, that will reduce to a 9 over 4. And the decimal equivalent for that is 2.25. We could substitute that in and verify that it is indeed a solution. Solve for the variable in bold. So here we see we have two variables, x and y. My variable y is in bold. I want to solve for this variable y. That means get this y by itself. Well, I noticed that we have a 4x on the same side as that y. We want to undo my 4x, get rid of it. It's a plus 4x, subtract 4x. What do we ever do to one side, we do to the other. Right. Keep my separator line here in the middle. 4x minus 4x leaves just the y. That's what we're trying to do, get y by itself. Equals in the middle. And I could simply write 10 minus 4x. However, in general, we will put our x term first. In this case, it's a negative 4x, positive 10. What's very important is we cannot subtract these. We cannot say 10 minus 4x and get 6x because these are unlike terms. unlike terms. Remember, like terms are same variable and same exponent. Here, x has the variable, 10 does not. We cannot go combining them. In order to combine, they must be like terms. Same variable, same exponent. These two are unlike. One has the variable, one does not. The correct answer is y is equal to negative 4x plus 10. Number 14. Again, we're solving for the one in bold, in this case y. So I see on the same side, we have this minus 6x. I will use my inverse operation, addition, adding 6x to both sides. Minus 6x plus 6x, sum to 0, leaving only 2y. Equals in the middle. 20 plus 6x, 26x? No. Again, unlike terms. One has an x, one does not. I will leave it separate. I could write 20 plus 6x, but indeed I will write my x term first. Positive 6x plus 20. Solving for y, we will divide by my coefficient 2. I could divide my whole side by 2. Equivalently, I'm going to divide each term by 2. This statement or this statement are both correct. This one perhaps is a little easier to see what we'll be left with. 2 divides 2 leaves y. 6x divided by 2 is a 3x. 20 divided by 2, that's 10. You could easily progress from this statement to this statement, realizing that 6x divided by 2 is going to be 3x, and 20 divided by 2 will be 10. Y is equal to 3x plus 10. Solve from a variable in bold. Solve for the variable in bold, in this case a. If we want to solve for a, we first undo our added or subtracted portion, in this case plus b. It is a plus b, so I will subtract b, the inverse operation. Whatever I do to one side of the equal sign, I do to the other. B subtracts b to leave a times x on the left. On the right side, we have c minus b. Well, we're looking to get the a by itself. What's keeping a from being by itself? X is. What operations are going on between a and x? It's multiply because they're connected. I want to undo that multiply by dividing, in this case dividing by x. You may be thinking, we typically divide by what's in front, the coefficient. Well, that's true, we typically do that. But with multiplication, order is commutative. We could certainly switch the order of these. A times x is the same as x times a. The key is we want to get the a by itself. So we need to undo this multiplied by x. So dividing by x on both sides. X divides x to leave a. That's what we were trying to get done. And we could leave it absolutely as c minus b over x. This is perfectly okay. An equivalent method that we just saw was c over x subtract b over x. And since we have no values for any of these, this is as simple as we could write it. This statement or this one would be okay in this case. Last problem, number 16. P is equal to 2L plus 2W. Hopefully you recognize this as the formula for perimeter of a rectangle. Perimeter is equal to 2 lengths plus 2 widths. And if I drew us a rectangle, you could see that. Let's say this length was 6, so naturally this one would be 6. And let's say this one width is 4, this one's 4. The perimeter is the sum of all those. It's 2 of these, right? 6 and 6 is 12. 2 of these, 4 and 4 is 8. The perimeter here is 20. The perimeter is the distance around the outside. Perimeter is 2 lengths and 2 widths. Well, here we're solving for W. Well, we want to get the W by itself. We will first undo the added or subtracted part, in this case the 2L. Separator line. I want to undo my plus 2L, I subtract 2L. Whatever I do to one side, I do to the other. 2L subtracts 2L, leaving 2W. These are unlike terms. I can't combine them. I will leave it as P minus 2L. Solving for W, I need to divide by this 2. Dividing by 2 on both sides. 2 divides 2 to leave me W equals, and I can leave it just like I see it. P minus 2L divided by 2. Or equivalently, I could divide each one of these by 2. So, I could state W is equal to P divided by 2. And this is minus 2L divided by 2, or those 2's would cancel to let's leave minus L. So what we have is the width is equal to the perimeter divided by 2, subtract the length. Let's use this formula we've created and see if it works for our particular rectangle. I'm rewriting this. W is equal to P divided by 2 minus L. So I've just recopied this statement, switching the sides. I can do that. That's the symmetric property. We can easily switch the sides that the expressions are on. Here, this statement's on the left. Here, it's on the right. Here, this one's on the right. Here, it's on the left. Symmetric property. Let's substitute our values here and see if we get a true statement. Our width, 6. Is it equal to our perimeter, which is 20, divided by 2 minus our length? Since I called this one 6, this other one I should call my length 4. Typically we use the longer side as our length, but it really does not matter which one we designate length and width. It does not matter. So, is 6 equal to 20 divided by 2? That's 10. 10 minus 4. Well, 10 minus 4 is 6. We have 6 is equal to 6, and that's a true statement. So that is one verification of our statement here. And that concludes this video.